there is a planet we gave up on a long time ago. We called it a dead world. Cold. Lifeless. A place with nothing left to hear. But in 2018, NASA still sent a machine there, not to search for life, but simply to listen.
5, 4, 3, 2, 0.
And it heard something. Tiny vibrations. Weak, but real. A planet humanity believed had stopped breathing billions of years ago was still trembling beneath that red dust. For the first time in history, humanity did not just see another planet. You're watching Astrexo. Before a planet finds its voice, there is always a moment of tense silence. In the early hours of May 5th, 2018, at Vandenberg Space Launch Complex 3E, scientists from NASA sat motionless in front of their screens while outside, darkness still covered the launch pad. There, the Atlas V stood towering nearly 197 feet tall, a machine powerful enough to carry tons of equipment away from Earth, yet never able to offer a sense of certainty. Rockets like this had flown dozens of times, but every countdown still felt like the first, because the history of Mars has never been easy. More than half of the missions had failed before they could even begin, or vanished the moment they reached their destination. Even this launch had once been delayed because of a small issue within the SEIS instrument.
What is that anomaly?
A detail significant enough to push the entire journey back by months. And that alone created an invisible pressure in this moment, where everything had to be perfect, yet nothing was guaranteed. Because at the very top of that machine was InSight, a lander not searching for images or signs of life, but carrying a quieter purpose. It wanted to listen. If it failed, everything would end right here before the journey could even begin. But if it succeeded, it would become the first instrument to let us hear the heartbeat of another planet. And that was a gamble humanity had never taken in quite this way before. This was not the first time humanity had tried to listen to a planet, but every previous attempt had ended in uncertainty. Viking 1 and Viking 2 once carried seismic instruments to Mars with the same hope, but the results were never clear. One instrument never functioned, while the other recorded signals no one could confirm, whether they were the subtle tremors of the planet's interior or merely the wind sweeping across its frozen surface. And that very uncertainty turned the data into unanswered questions for decades. This time, everything had to be different. With InSight, scientists sought to erase the fragile boundary between signal and noise, between truth and illusion. Meanwhile, at the launch site, the final parameters were being confirmed.
Fuel pressure nominal.
Weather data streamed in continuously, each small number capable of determining the fate of the entire mission. Launching a rocket has never been just about igniting engines, but a complex equation where wind, clouds, and even solar activity can interfere with every second of the countdown. Then the signal was sent. All conditions were accepted. A narrow window opened within the chaos of nature. InSight was now less than an hour away from leaving Earth, and everything ahead would either reveal an entirely new understanding of Mars or fall back into silence just like before. To understand a planet, sometimes we don't need to look at its surface, but to listen to what lies deep beneath. InSight is not large, not complex in the way we often imagine machines of space exploration. Yet that very simplicity is its strength. Resting still on the surface of Mars, it deploys a seismic instrument shielded from the wind, gently placed onto the ground by a robotic arm, as if touching an unfamiliar body in search of a heartbeat. And then it waits. When the first vibrations ripple through the mantle, whether from a faint Marsquake or a meteorite impact on the far side of the planet, this instrument records it all. But what truly changes our perspective is not the detection of vibrations, but how they are decoded. Tiny differences in the travel time of various wave types allow scientists to reconstruct the internal structure of an entire planet without ever having to dig into it. For the first time, Mars is no longer a silent surface, but a system that can be seen from within. To ensure that what is heard is not an illusion of the wind, InSight carries environmental sensors, separating noise from signal, making the data reliable in a way previous missions never achieved. And deeper still, a small device known as the mole drives itself into the ground to measure the remaining heat, tracing the thermal past that shaped this world. This is not merely about collecting data, but an effort to push beyond the limits of human understanding. Because as the structure of Mars is gradually revealed, a greater question begins to emerge. If we understand how a rocky planet forms and evolves, is Earth truly unique, or just one possibility among countless outcomes? How many other worlds were once like us, and how many of them have fallen silent forever? Every journey to Mars begins with a gamble against force and heat. Around 4 a.m., InSight left Earth aboard the Atlas V, where acceleration pressed against the spacecraft's body to the point of nearly breaking every physical limit it was built to endure. In the first few minutes, the first stage burned through its fuel and separated, giving way to the Centaur upper stage to continue pushing the spacecraft beyond the planet's gravity. This was the first step, and also the most predictable, because the rest of the journey unfolded in absolute silence. 6.5 months passed through the cold vacuum, where there is no wind, no sound, only a small object drifting across a distance of nearly 310 million miles. Yet, that quiet concealed an ending that would be anything but. As it approached Mars, everything changed within a few brief minutes. The spacecraft plunged into the atmosphere at an altitude of over 62 miles, traveling at nearly 12,400 miles per hour, generating a blazing sheath of plasma around its body. Temperatures surged to about 2,700 degrees Fahrenheit, enough to destroy anything unprotected. The heat shield absorbed that fury, keeping the interior from burning away. As the speed dropped, a supersonic parachute deployed in an atmosphere barely thick enough to create drag, yet just enough to make the difference between survival and failure. And that is the paradox. Mars has an atmosphere, but not enough to save you. Everything is only just enough to buy time, never enough to guarantee safety. The next few minutes would decide everything. There are moments in the universe when every calculation comes to an end, and only a few minutes remain to survive. InSight does not rely on luck. It was built for this. When the parachute completed its task and separated, the spacecraft had nothing left but itself within the thin sky of Mars. Its landing legs deployed, the descent engines ignited, holding it in a fragile balance between free fall and control. In those brief minutes, it had to guide itself precisely to the surface. There was no second chance. Then the moment arrived. On November 26, 2018, InSight touched down. The final engines blasted red dust into the air, creating a hazy veil that surrounded it. But even after a successful landing, the risk was not over. That dust could reduce its chances of survival. So, InSight waited. 16 minutes passed in silence before its solar panels slowly unfolded, reaching for the only source of energy it could rely on. Under ideal conditions, they generated a few hundred watts of power, but on Mars, nothing is stable. Dust in the atmosphere can reduce energy at any moment, like clouds covering the sun on Earth, except here, it can last for weeks, even months. And when it looked out across its surroundings, there was nothing but rock, dust, and an almost absolute stillness. This is not a place for exploration in the way we are used to. InSight does not move. It does not need to, because its mission is not about distance, but about depth. It will remain here for years, listening, collecting, and waiting, and in that silence, a planet will begin to reveal its secrets. At the moment a lander touches down on a distant surface, the biggest question is not whether it survived, but whether we can hear its answer. Above the thin atmosphere of Mars, two small points of light appeared. Not stars, but Marco A and Marco B. They did not explore, they did not take images, they simply listened. For months, these tiny satellites had followed InSight, waiting for the most critical moment to carry out their role. And that role was simple, yet vital. When InSight landed, every signal it sent had to travel across millions of miles to return to Earth. And without assistance, we would have been left waiting in silence. Marcio changed that. These small metal boxes, no larger than a briefcase, marked the first time humanity sent CubeSat technology into deep space. An experiment no one was certain would succeed. But here, in the cold distance, they proved something important. We do not need massive machines to connect planets. We only need precision. With just a few dozen watts of power, they captured the faint signals from the surface of Mars, then amplified them and sent them across space, back to where everything began. And in that moment, the distance between two planets was no longer silence. It became a conversation. In space, there is no room for absolute dependence. NASA has never placed everything on an unproven technology. If Marco A and Marco B had failed, there were still orbiters like Mars Reconnaissance Orbiter ready to listen. Slower, more fragmented, but enough to ensure that silence would not be the end. As for Marco, their mission lasted only a brief moment before ending in a way that was almost forgotten. Unable to slow down and remain, They swept past Mars and continued drifting around the sun, becoming messengers that would never return. But InSight did not know that. For it, everything had only just begun. After touching down, the first signal was sent. A simple message, yet carrying the weight of the entire mission. It had arrived. Along with it came the first image, blurred and covered in dust, as if the planet itself was not yet ready to be seen clearly. Dust from the landing still clung to the protective cover of the lens, a detail anticipated long before. And when that cover was removed, clearer images began to emerge. A new perspective on an old world. Below, the camera captured the marks left by the landing itself, where the engines had blasted away the soil and carved small impressions beneath the spacecraft. A reminder that even a gentle touch on Mars is enough to alter its surface. And in the stillness that followed, InSight began to do what it was created to do. It did not move. It did not rush. It simply listened. Sometimes, the fastest way to understand a planet is to listen to what we cannot hear. After deploying its solar panels and stabilizing on the surface, InSight began working immediately, even before its main instruments were placed on the ground. And the first thing it recorded was not a quake, but the wind. Tiny vibrations traveled through the body of the lander, reaching the seismometer still resting on the deck, converted into a sound humans could perceive. A low, almost non-existent hum, yet enough to prove that Mars is not completely silent. When amplified, these oscillations revealed an unexpected reality. Even though Mars's atmosphere is far thinner than that of Earth, it is still enough to create motion, enough to carry energy, enough to leave a trace. Not only that, InSight also recorded pressure changes as gusts passed by, turning invisible fluctuations into measurable data. And then another detail emerged, subtle yet important. Clouds of water ice drifted across the sky, reflecting light and revealing the direction of the winds. This was the turning point. Mars may be dry and cold, but it is not dead. It still has weather. It still has motion. It still has an atmospheric cycle, fragile as it may be. And from those faint vibrations, a planet that once seemed silent began to feel alive in a way we had never imagined. To hear a planet, you first have to find the place where it is willing to speak. After completing its initial preparations, InSight entered its most critical moment, deploying the SEIS instrument. But this instrument could not function while it remained on the lander. It had to make direct contact with the ground, where real vibrations travel, and that was the challenge. Not every location is quiet enough to listen to a planet for years. A small rock, a slight tilt in the surface, or even a gap beneath the windshield could turn valuable data into noise. So, before it could listen, InSight had to observe. It captured images of its surroundings, building a detailed three-dimensional model, every contour of the terrain reconstructed back on Earth. Engineers did not just look at it, they stepped inside that environment through virtual reality, searching for a location where every variable could be controlled. This was no longer about placing an instrument, but about finding a perfect point within natural chaos. Once the site was chosen, the robotic arm began to move, slowly and precisely. Placing SEIS onto the surface of Mars, as if setting a microphone onto a planet. And then everything fell silent. No movement. No sound. Yet, within that silence, the first vibrations began to emerge. Faint signals, almost invisible, but enough to tell the story hidden deep inside a world that had remained quiet for billions of years. There are missions in space that fail not because of a lack of technology, but because we misunderstood the very planet we set out to touch. After InSight stabilized and began listening, it was time for the instrument expected to dig into the past of Mars, the device nicknamed the Mole. It did not drill in the conventional sense. Instead, it hammered itself into the ground, one small stroke at a time, relying on the friction of the surrounding soil to move deeper, with the goal of reaching several meters beneath the surface. On Earth, every test showed it worked perfectly. But on Mars, everything nearly stopped at once. After just a few inches, it became stuck. Not because of a large rock, but something far more subtle. The Martian soil did not behave as expected. It did not provide enough friction to hold the device in place as it hammered. And that was the turning point. We had brought the right solution for the wrong world. From that moment on, the mission was no longer just about exploring the planet, but about struggling to understand why our technology did not fit this environment. Engineers back on Earth began intervening remotely, using the robotic arm, never designed for this task, to try to salvage the situation. They removed the protective casing, observed, tested step by step, even using the arm to press the soil around it, hoping to create enough friction for the device to continue moving.
Again, slightly lower.
But every action had to be slow and precise, because a single mistake could end all remaining chances. Time passed not in hours, but in months. And in that delay, a truth slowly emerged. Mars is not just a simpler version of Earth. Even its soil follows different rules. And sometimes, failures like this reveal more than any success ever could. Sometimes, in the middle of prolonged failure, a single faint signal is enough to change the entire story. In April, InSight recorded the first Marsquake on Mars, a tremor so weak that the human ear could not perceive it without conversion. But what mattered was not the sound, it was the meaning behind it. A planet once believed to be still was, in fact, still in motion. And the SEIS instrument proved it with near absolute sensitivity. It did not just record seismic activity. It could feel the wind passing by, even the slightest movements of the robotic arm from a distance. This was no longer ordinary measurement, but a level of observation where the boundary between signal and noise became razor thin. But InSight was not only listening to the ground, it was also monitoring the atmosphere like a solitary weather station in the cold equatorial region of Mars. Temperatures could drop far below freezing, cold enough to destroy any mechanical system without protection. The pressure was so low it was almost non-existent, and winds that seemed weak could still reach significant speeds in such a thin environment. This is the paradox of Mars. A world just enough to create motion, but not enough to protect anything that exists on it. And within that reality, InSight continued to operate, collecting its first data while confronting limits no simulation on Earth could fully recreate. Its mission was no longer a simple story of success or failure. It became a journey of contradictions, where every new discovery came with a new challenge, And that is precisely what makes Mars so difficult to truly understand. Sometimes, to understand a failure, we have to give it time to reveal itself. Months passed and InSight was approaching its first year on Mars, yet the question of the mole remained unanswered. At first, the idea of a solid rock blocking its path seemed reasonable, but as the data was analyzed more deeply, that assumption gradually collapsed. The landing site had been chosen for its lack of large rocks, and the design of the device was flexible enough to avoid smaller obstacles. The problem lay elsewhere. Back on Earth, scientists began reconstructing every detail, using images from Mars to simulate the environment around the instrument. But there was a limit they could not overcome. The gravity of Mars could never be perfectly recreated. No matter how materials were adjusted, no matter how precise the models became, there was always a margin of error that could not be eliminated. And within that margin, the answer slowly emerged. By October 2019, a conclusion was becoming clear. The problem was not what blocked the path ahead, but what was missing around it. The Martian soil did not provide enough friction to hold the device in place as it hammered itself downward. A small detail, almost insignificant, yet enough to render the entire design ineffective. This was the true turning point. Not that the environment was too harsh, but that we had not understood it deeply enough. And sometimes a planet does not need to resist you. It only needs to be slightly different from what you expected. Sometimes a planet does not reject you immediately, but lets you realize on your own that you misunderstood it. As the soil around the mole was gradually revealed through images from InSight, a truth began to take shape. The surface appeared loose, light, and dusty, seemingly perfect for digging. But just beneath it lay another layer, harder and more cohesive, an invisible crust known as duricrust. And it was this very layer that shattered the original assumptions. Instead of collapsing to create friction as expected, the soil particles bonded together, holding their structure and preventing the device from driving itself deeper. This was not an obstacle, but a different rule of the planet. A small detail, yet enough to render the entire design ineffective. From Earth, engineers began a series of efforts that stretched over months. They tried holding the device in place, filling the gaps with soil, even intervening with the robotic arm despite it not being designed for such a task. Every step was cautious, because even the smallest miscalculation could permanently damage the system. Time moved slowly, measured not in days but in failed attempts. Eventually, when they decided to press directly on the device, a brief moment of hope appeared. It sank, but then it stopped. There was no further progress, and by early 2021, they were forced to accept something every mission must face at some point. Not everything can be saved. Yet, within that failure, a new understanding emerged. Mars is not only different in its atmosphere or temperature, but even its soil follows rules we have never experienced. Meanwhile, the SEIS instrument continued working in silence. More than 2 years of listening, hundreds of tremors recorded, and from those signals, a picture slowly began to form. Mars does not have tectonic plates like Earth, but it still moves. Seismic waves travel through the planet's interior, reflecting through each internal layer, carrying information about structures we had never seen before. This is the final paradox. One instrument failed to dig deeper, yet another allowed us to see deeper than ever without touching it. And perhaps that is how the universe always works. It does not give us answers in the way we expect, but in a way that forces us to change how we ask the questions. There are secrets that do not reveal themselves through what we see, but through what we miss. From hundreds of signals collected, InSight began to unveil an unexpected picture of Mars. Quakes occurred frequently, yet they were weak. There were no tremors strong enough to immediately reshape our understanding, and that created a difficult gap to explain. Is this planet truly quieter than we thought, or have we simply not witnessed the rare moment when it truly speaks? The answer remains unclear, but something else became clearer. The SEIS instrument was too sensitive. So sensitive that it did not just hear the ground, but the wind as well. Faint vibrations from the atmosphere could completely mask seismic signals, like interference erasing an important sound. And that is the turning point.
It's exactly where
Not because we lack data, but because too much is competing within the same signal space. During periods of strong winds, the number of detected quakes seemed to decrease, but in reality, they were simply hidden. To deal with this, scientists had to change their approach. They could not turn off the wind on Mars, but they could come close to it. By using the robotic arm to partially shield the instrument, they tried to create an artificial pocket of silence, a place where true vibrations could emerge. And in a world where even the air itself can deceive you, finding true silence becomes the greatest challenge of all. Sometimes the strangest thing is not what we find, but what should exist and yet is completely absent. When scientists analyzed the data from the SEIS instrument on InSight, they realized something almost unbelievable. Marsquakes still generated waves that traveled through the planet's interior, but the familiar type of wave that moves along the surface never appeared. A gap in the data where the clearest signal should have been, and that absence became the clue. It suggested that the upper crust of Mars might not be as solid as we once believed, but fractured, scattering energy before it could propagate. If that is true, then the planet's surface is not only dry, but broken in a far deeper way than we ever imagined. But to be certain, more time was needed. And time was exactly what InSight was slowly losing. Inside, every system continued to function, but outside, a quiet threat was building. Dust. Not a massive storm, but thin layers settling over time, clinging to the solar panels, cutting away the only source of energy sustaining the entire mission. There was no way to clean it, no mechanism to resist it. Only hope that rare dust devils might pass by and sweep it away. But that hope never came. As energy declined, every decision became more difficult. Which instruments to maintain? Which systems to shut down? Preserve survival, or continue the science? And then an unavoidable choice emerged. InSight had to sleep. Not because its mission was complete, but because it no longer had enough power to continue. In the cold winter of Mars, when the planet is farthest from the sun, the spacecraft slowly withdrew, conserving its last remaining warmth just to survive. And in that silence, one question remains suspended. When the light returns, will it wake up and continue listening, Or is this the end of a conversation that had only just begun? Some machines do not stop because they complete their mission, but because they slowly run out while still trying to continue. When spring returned to Mars, InSight woke from its long sleep, but it was no longer what it once had been. Its systems restarted, yet the energy was no longer enough. Dust still clung to its solar panels, thicker with each passing day, blocking the only light it could receive. This was no longer a technical problem, but a physical limit that could not be overcome. InSight began to realize what every mission must eventually face. It would never be as strong again, and within that weakened state, an unexpected decision was made. NASA extended the mission. Not because conditions were favorable, but because what InSight had already achieved was too valuable to stop. And so it continued. Not with its original strength, but with what little energy remained. One final effort. Hundreds of quakes had been recorded, yet none were strong enough to reshape the entire picture. And that became the final goal. A tremor powerful enough to reveal deeper layers of the planet. But time was not on its side. Energy declined day by day, from a level once sufficient to sustain stable operations, now reduced to a fragile fraction, like a fading light. This was a race with a predetermined end. Not whether InSight would stop, but whether it could listen to one more secret before everything fell silent. And millions of miles away, humanity kept watching, hoping to extend each passing moment, just to hear one last heartbeat from a distant world. Sometimes, to save a machine that is slowly fading, we are forced to do the opposite of instinct. In early June 2021, an idea that seemed almost absurd appeared. Cleaning dust with dust. InSight had no sophisticated tools for self-maintenance, only a rough robotic arm with a simple scoop. But instead of removing the dust directly, engineers decided to sprinkle sand onto the solar panels at the right moment, letting the wind carry those grains across the surface to knock away the older layer of dust. A risky method,
is too close.
almost counterintuitive at first glance.
What is the damage?
But it worked. Not dramatically, just a small increase in energy each day, but enough to extend its life. And sometimes, a little more time is all it takes to change the outcome. With that borrowed time, InSight moved into another year, crossing a boundary it was never expected to reach. And then, what scientists had been waiting for finally happened. In its final year, when energy was nearly depleted, the planet began to tremble more strongly than ever. The SEIS instrument recorded a signal unlike the others, larger, deeper, a magnitude 5 Marsquake, a rare scale on a planet without plate tectonics like Mars. This was the final turning point. Not when InSight was at its peak, but when it was close to the end, it captured its most valuable data. And that raises a familiar question, one that has never had an easy answer. Perhaps, in the universe, the most important discoveries only appear when we have reached our very limits. Some missions do not end with noise, but with a silence that was always expected. By the end of 2022, as InSight entered its final days, NASA did not shut the spacecraft down. They gathered what it had left behind. The data was organized, opened for the world to continue decoding. And from that, a new picture of Mars began to emerge. not a dead rock, but a planet with a defined structure, crust, mantle, and core. Yet everything shifted away from expectation. The crust is thinner, the mantle is cooler, and the core is larger but less dense. This is the turning point. The core does not consist only of heavy metals, but also lighter elements, forcing us to rethink how a planet forms. Mars is not a smaller version of Earth. It is a different path entirely. And when we compare these two worlds, the question is no longer how similar they are, but why they are so different. In the final silence of InSight, what remains is not an ending, but new questions, deeper and more difficult than ever before. Some planetary secrets do not lie on the surface, but deep within how a world was formed. From the data gathered by InSight, we realized something crucial. The core of Mars is not like that of Earth. It contains a higher proportion of lighter elements, and that is what prevents it from fully solidifying. This is the key turning point. It suggests that Mars formed in a different environment, one where those elements were still abundant. When the planet was young, molten material allowed heavy metals to sink and form the core. At that time, the core was dynamic, generating a magnetic field that enveloped the planet. But over time, energy declined. The core cooled, its motion slowed, and the magnetic field disappeared. What remains today are only faint traces preserved in rock. What is striking is not that Mars lost its magnetic field, but that it once had a phase active enough to create one. And that forces us to look again. Mars was not a world born dead. It was once alive, it simply did not last as long as Earth. Sometimes the greatest value of a mission lies not in the answers it provides, but in the questions it leaves behind. Thanks to data from InSight, we are beginning to better understand when the magnetic field of Mars once existed. And that matters more than how it appears. Because a magnetic field is not just a physical phenomenon. It determines how a planet retains its atmosphere, and from that, its potential to support life. This is the crucial point. If we can identify when the dynamo is active and when it shut down, we can define the window of time when Mars may have offered the most favorable conditions for life. But at the same time, this data is overturning many long-held assumptions. One of the greatest mysteries lies in the Tharsis region, home to the massive Olympus Mons. The heat source that sustained volcanic activity there was once thought to come from deep within the mantle. But now, knowing that Mars does not share that kind of internal structure, the entire explanation must be reconsidered from the beginning, and that is the final turning point. The more we understand Mars, the more we realize how deeply we misunderstood it. But that is not failure. That is how science moves forward. The data is still there, waiting to be analyzed. Each seismic wave still being decoded, like lingering heartbeats of a planet that has been silent for far too long. And even though InSight has powered down, its story is not over. It has only just been handed to us. Thank you for staying with Astrexo until the end of this journey. If today's story made the universe feel just a little closer, don't forget to like, share, and leave your thoughts in the comments. Your support is what drives Astrexo to keep telling deeper, farther-reaching stories about the vastness of space. And if you haven't subscribed yet, make sure to hit subscribe so you don't miss the journeys ahead. See you in the discoveries to come.